All glass that goes through a heat treating process is distorted to some degree by the heating and cooling process. Traditionally, this distortion was viewed using a zebra board. This was a visual analysis where the zebra line pattern would be distorted by the variations in the glass. For an experienced operator, this qualitative analysis allowed them to assess the end quality of their product as it exited the line. However, no historical reference could be retained for comparison to issues in the field.
One of the other methods of measuring distortion in glass is to measure the roller wave using a flat bar or a 3-point measuring device. Essentially, it is just dragged across the glass, and the physical measurement is weighed of the peaks and valleys within the glass. One of the problems with this is that you cannot measure the outside 6 to 8 inches of the glass doing this. The Osprey light sentry system allows us to get a full measurement across the full width of the glass, giving us complete data, and this is excellent data to use, especially when we have edge curl problems for a laminated product.
In 2012, AGNORA acquired the latest equipment for quantitative glass distortion evaluation. This unit uses CCD cameras to visually capture the distortion a human eye would observe. The difference being is that the eye is calibrated and not prone to human variation. The unit measures the curvature of the glass in approximately 1-inch diameter areas across the entire piece of glass. The measurement is then displayed in a visual fashion for the operator to see, but also as a numerical measurement that the operator can compare to standards.
The data is displayed to the operator as peak to valley measurements and as a millidiopter measurement. The peak to valley measurements, ones here, are the ones that reflect roller waves, so the amount of variation that goes up and down within the glass. The glass is also physically displayed and reflected as a number in terms of millidiopters. This number is associated with the curvature of the glass at any given point. So the coloration on this side shows the variation from the norm at any small piece within the glass. It's approximately done on a 1-inch glass basis. And it will vary depending on the actual location in the glass, the front end, the back end, wherever else.
The data is based on the radius of curvature of the glass in any given small area. These values can be associated with what the human eye will see when it looks at the actual glass surface. The measurement takes into account all types of distortion in the glass, not just roller wave. Since implementation, the consistency of data has allowed us to make ongoing improvements to our product recipes. This has led to less waste and overall improved visual characteristics of our final product.